Hello and welcome to another video of binary search, modified binary search actually. Today we'll be doing a problem called ceiling of a number, or I just called it ceiling binary search. Uh, yeah. Anyways, reading the problem statement, given an array of numbers sorted in an ascending order, find the ceiling of a given number key. The ceiling of the key will be the smallest element in the given array greater than or equal to the key. Write a function to return the index of the ceiling of the key. If there isn't any ceiling, return -1. And with the example, we have an array with 1, 3, 8, 10, and 15, and the key is 12. The output is 4 because the smallest number greater than or equal to 12 is 15, having an index of 4. So yeah, this is just a different version of a binary search, and so we just have to obviously modify it a little bit, and we can make our solution work. So we're going to start with two variables, left and right. We're going to initialize left with the value of 0, right with the value of length array -1, right? And then so here we will do if key is greater than array right, then we know we can just return -1 because there is no value in this array that can satisfy the return solution value. And then so we already have our variables for the modified binary search. So while left is less than or equal to right, because if we stop on one number, it's possible that that one number is the answer. So we have to check that condition as well. And so we calculate mid is equal to left plus right minus left floor division 2. The reason I explained this in the last video, but the reason why we do this as opposed to something like mid is equal to left, left plus right floor division 2 is because this could potentially overflow. Honestly, in modern computers, you might not get that problem, but potentially you still could. So the safest option is just to do this where you have left and then you find how many indices over is the midpoint, and then you just add it to left. So you're guaranteed to be able to get there because right is already a bigger value than left. So from here, we want to do a few, I guess, checks in a sense. If array mid is equal to the key, then we just return mid. Pretty simple, self-explanatory. Else if array mid is less than the key, then we know since our current key is less, right, we need to move to the right. So start is equal to mid plus 1. Else, so this would count for the case of array mid is greater than key. So we want to go to the left, right, because it's too big. So start is equal to mid, well, not start, sorry, not even start, what am I doing? It's left, and then right is equal to mid minus 1, because it's, if the value is too big, we need to go the other way, right? And by doing this, it guarantees if we ever do hit the same number here, if it's not equal to the key, we will eventually make it so that we're not stuck in an infinite loop here, right? And so we'll eventually exit, and here we'll return start. Not start, what the hell? Left. Because, okay, I don't want that. We would return left because, that means we were able to find a number that is greater than our key, but then we weren't able to find one that was exactly the same, right? Because eventually left will be further right than right. That's kind of confusing, but left will have a higher index than right. And then since it is possible to find an answer within our array, we know that left will point us to the right answer. That makes sense because we always want to move to the right or like a higher index compared to our mid if it's less than. And like even here, right, like our right will be less, like further over to the left or like smaller indices compared to key. So we can't use right? So we'll just return our left value. And so here our solutions would look like index 1 here because 6 is actually found in here. 12, this is the example that we see above. It would be in index 4, 0, 1, 2, 3, 4. This one, 17 is way too big for this, so we'll have a -1 return. Whoops, I don't want to do that. And here, -1, since it's the smallest number, we will just keep moving until right becomes -1 because this is 0, right? So we actually return 0 for this. So our total or like final solutions we should see would be 1, 4, what the hell? 1, 4, -1, and 0. So if we run this in 1, 4, -1, and 0, there we go. And yeah, with that being said, thank you for watching.